Hi, Imran. How are you doing? Hi, everyone.
I'm doing well. How about you, Salman?
I'm good.
Nice.
Thank you.
Let's wait for a few more minutes.
Mm-hmm.
So today, like we decided last time, since we are putting a lot of time on the Sundays meeting, so I'm just telling everyone today we'll try to finish our meeting by 9:45 max, because
Mm-hmm.
the work day, many people have other commitments as well. So, yeah. So maybe the tentative plan is to maybe our task lead will, Salman in this case. I know Rich is busy, he has some work commitments. He will try to get it done by hopefully 9:30. Do you think, is it fair? Do you think we'll be able to finish by then, Salman?
Yes, because I think I explained majority of the stuff in my
Right.
last meeting. So today, most probably, I would be just talking about different tests, parametric and non-parametric, hypothesis testing, and scatter plots. So that is the only thing which we did not cover last time. So I think we would be able to do it. So I would start from the top, but I would not go deep down on the things I talked about last time. Means since the video is already on YouTube, so anybody who missed it, they can go and watch it, and then we can kind of like talk about the stuff that we have not talked about. For example, like I know that parametric and non-parametric test, there is a lot of confusion out there. Anybody who is new to statistics, they are confused. So I did some research, covered some theory. So I will talk about some things, when to use which one, and things like that.
Oh, good.
Mm-hmm.
Yeah, so I think half an hour will be enough on your end, and I think 10-15 minutes we can leave for question answers if somebody has.
Mm-hmm. Sounds good. And so you want to start, or should I start? Means you have to do something.
I'm just
Obviously, you
waiting
do something in
for
the beginning.
just a little bit, and then very quick announcements I have to make for 2 minutes, and then it's all yours.
Okay, sounds good. And meanwhile, can you
Oh,
let me share
sorry.
my
Thanks.
screen,
My
please?
apologies. Yes. Okay, guys, time to get started.
Good. Okay, so
I mean,
we
let
will
me
get started.
I mean, 2 minutes
Okay.
announcement I'm gonna make, and then we're gonna get started. Sorry about that. So at
Sounds
least
good.
in the
Sounds
end, we
good.
can just take over all. Good morning, everyone, or good evening, everyone. Today we have a second task meeting of the exploratory data analysis. And today is the final meeting for this task. Some quick things in our agenda, very quick, before I pass it down to Salman. Our task lead for project management, she created GitHub link, which I showed you guys last time. There's also a Google Sheet link, which is already posted in our project management folder. So just a reminder, it's here. All tasks are here, all task details are here, status is here, reference is here. Feel free to assign yourself. I understand for this class might be late for future tasks when she posts, or so you feel free to assign your name, put your initials, so at least we know, or task leads know that somebody else is contributing, and it will really help us to work as a team. And if there's any concern, if you don't like Google Sheets or anything, if you want some changes, feel free to message us, so at least we can change our strategy. And or if you know any better platform, feel free to let us know, so at least we can consider that. Project evaluation, thanks to all of you who have already did those evaluation. It was really helpful. We also would like, there are some other participants, if they can put it their evals as well, so at least we can get a holistic picture, and then we can alter our strategy accordingly. We're already halfway done with the project. Please subscribe to this YouTube channel our task leads Rich and Salman has created. So please help grow this channel. I'm sharing the link of this in our chat. How do I do that? So please do it. And also support us on our LinkedIn channel as well. The link I'm posting here for your convenience. And then there's an unexpected announcement came up this. Sorry about that. This morning, I messaged our task leads and I asked them if they can volunteer to help some of the participants to break down the task feature and some general concerns they have. And that just shows their great work ethics. I really just love it. I mean, readily, both of them were agreed to volunteer the time, and I know both of them are working professionals too. So we all, as the participants, I think I'm personally very grateful, and we all, as a participants, we all should be grateful. Feel free to message them for thank you, and we're deeply, sincerely thankful for them for sure. Now I'm going to pass it down to Salman to carry over.
So, okay, so for EDA, last time we discussed that we did the univariate analysis, in which we looked at one individual column at a time, and we looked at the distribution. We tried different strategies for getting rid of the outliers. We talked about different strategies. So technically in EDA, we analyzed a lot of stuff. We gathered a lot of information, and we will use that information in feature engineering part, because I figured out few important details. For example, we learned that there are 3 columns related to wind, which has a lot of missing values. And then there is a column for fog, which has a lot of missing values. And we were thinking that those values are missing or things like that. But when I analyzed it again, this is the kind of like thing happens when you are looking at the data from all different angles. You can see some things which are usually in the first go you can miss. So what I able to see was something very
What happened?
Yeah, we lost him.
keep one thing in mind.
Hey, Salman.
The data that we
lost
have,
you. I think
it
there was
is
some,
yeah.
There was some connection problem on your end. So can you please just repeat?
Okay, so I was saying that You can hear me now?
Yes. Can everybody hear him?
Yeah, now yes.
Yeah.
Okay, good. Thank you.
Okay, sounds good. So what I was saying was that this direction max wind column, this direction peak wind column, maximum wind column in days with fog. If you remember, our data has several buildings, and the data was recorded for those buildings for 7 years. That means if we are right, and I saw that one building has data for 7 years, and we are getting the values of the direction maximum wind for the whole year. If we go and read about the description of all our variables that are in it. So right now I'm using my laptop. I don't have all the things, but still I would just use data to open it. Yes. So if we read the definitions over here, you can see that direction max wind is telling you that wind direction for maximum wind speed at the location of the building. So which means at that particular location, what is the maximum value? So we can try and we can kind of like get the values for several buildings. If, for example, if one of the value in one of the year was given or something, we can kind of like use it to interpolate the data for the rest of the missing values for that particular building. So this is something we can do, because if we try to do that this way, maybe we will be able to fill up a lot of data values, which are not just random guesses, which are kind of like realistic values. So we can try to kind of like use these values in this particular manner. So when we were doing correlation analysis, in correlation analysis, we saw that direction max wind, direction peak wind, and max wind has not a lot of correlation with our target variable, but days with fog does have. So which means if we can kind of like get the values for this particular column somehow, it would make our model something good. Means it would be a very good feature. At least it is bringing some extra information in terms of prediction and everything. So we can try whether it is bringing some information or not. So in correlation, we will see that. So what we did is we basically just look at all the things during the univariate analysis. We looked at every single individual. So the distribution of every single. So this is floor area. We can see that the floor area, the distribution is kind of like skewed. So we talked about last time what is skew and what is kurtosis. So skewness is when it is kind of like whether around the mean, does it look exactly the same on both sides or not? If it's kind of like based on symmetry. So if it is not symmetrical about the mean position, it is skewed. So this one is called positively skewed. So how do we tell whether it is positive or negative? You look at the mean and median value. If mean is on the positive side of the median, it is positively skewed. And if it is on the left-hand side or the negative side, it is negatively skewed. So in this scenario, you can see that. So we will talk about it when we talk about hypothesis testing. So there are two different types of hypothesis testing that can happen depending on what kind of data you have. One is called parametric and one is called non-parametric. So the difference between the two, you must have heard about a lot of names. So there is a t-test and there is a z-test, and then there are chi-square test, then there are Kruskal-Wallis test, Wilcoxon test. There are so many Friedman tests, so many tests. Excuse me. Okay, so a lot of people get confused when they search about hypothesis testing. A lot of tests come up and they don't know which one to use in which scenario. So we will talk about it today. The one thing that I can tell you between parametric and non-parametric is if the distribution is kind of like mean value is telling you good story about the data, then you go with the parametric test. And if the median value is good indicator of the central value of the distribution of the data, then we go with the non-parametric test. That is the basic simple application of it. So if the mean is good representative of the distribution, we go with. So technically, in which situation mean would be a good indicator? normal distribution. So if your distribution is close to normal, then mean is a good indicator for the whole distribution as the central value. But if it is not normally distributed, then median is a good indicator, because median is not affected by the outliers in the data. So because what median is technically the central value. So it doesn't matter if my last values are pretty big or small, as long as I have equal number of values on both sides, my median would be the central value. So which means median does not get affected by the size of the values, which are the minimum and the maximum values. But mean does get affected, because mean is technically when you add all the values and divide by number of samples, then you get the mean, which means if you are adding bigger or smaller values, it will change the overall size. So these things we need to keep in mind, and these things kind of like make your life comparatively easier. So I just did those tests just to show you how to do it. But technically in these scenarios, you can see a lot of variables. They are not normally distributed, which means we cannot use majority of the cases. We cannot use the simple normal distribution test like t-test, z-test, and chi-square test. But I still did it. I just wanted to show you how to do it. So I will go through that. So we talked about the distribution and how we can fix it. For example, over here, I tried to get rid of the outliers by using the IQR range and using the 3 standard deviation rule. So yes, 3 standard deviation rule is something, but you saw that last time I changed the number to be 4.5. And I was watching the video last time, which I explained. I think Imran asked me the question that why I chose the number 4.5. So I think it's a bigger number. So over here, this is 4.5. When I tried 4.5, if you look at IQR range, it is 103,000. So when I multiplied with 4.5, it does not give me 1.5 million. So here I tried 4.5, and when I was kind of like getting rid of the outliers down here, that number, very slow. So that number was pretty small and I was losing a lot of data. That's why I changed this number a bit bigger, but I did not change this number. So this number technically should be a bit bigger. Means whatever the number over here is, you can find it. You can divide 1.5 million by this number, and you can find what number you need to multiply with in order to get that answer. So we can do that. So I just played with that number. So this is the number. It's your choice how much you are willing or to lose a particular amount of data. You want to lose, you are good with losing 4,000 values, then go ahead, do it 4.5. If you are willing to lose 8,000 or 15,000, just do 1.5, which is the standard. And then you would be losing 15,000 values. But I don't want to lose a lot of data, because if we are at the beginning stage, we don't know which strategy would work or everything. So these are the things we are keeping in mind. That means when we are making model and we are not able to improve the results of our model or something, maybe we can come back and we can change these numbers again. Okay, so we looked at the distribution of every single thing. Over here, I reduced the outliers, get rid of some of the outliers, and you can see it kind of like converted into close to a normal distribution. Even though it is still not a normal distribution, we can convert it. As last time Rich was saying that we usually, before putting it through the model, we kind of like standardize it as well, because that is a standard practice. So what it does is basically, so if you think in terms of that way, that for example, if you look at this data, floor area, the values are pretty big. As compared to star rating, it is 30. Machine does not know. The machine learning algorithms, they do not know. They only understand if the value is big, that means more weightage. If the value is small, that means less weightage. Which means if this column has a lot of big values, which means machine would be understanding that this column has more weightage than the energy star rating. That is the reason why we need to. I think last time somebody was saying that we need to talk about why we need that. So this is something I thought we will talk about it. So that is the reason why we don't want machine to pick and choose based on the numbers that we are inputting. What we do is we basically convert every single number between -1 and 1, which means when we standardize this particular way, this way every particular variable is getting the same weightage as we are inputting it. then machine decides on its own. The algorithm decides on its own which one should have more weightage depending on the distribution of the data that we have and things like that. Okay. So we fixed the distribution over here, and I showed that over here I used simply 3 standard deviation rule. In fact, IQR range, but then I showed also the 3 standard deviation in the next one. So over here you can see that this is kind of like we can fix it. I did not do anything with this one, but if you look at the skewness and kurtosis, this is 8. We can get rid of some of the values beyond 300. So this way we can kind of like get it to some sort of a normal distribution, but eventually when we standardize it, it would kind of like convert into a standard normal distribution. So this one, the same thing, kurtosis is pretty close to 3. So we are happy with that. We don't want to do anything. And for some reason, when I was doing correlation analysis, I saw that elevation does not have good correlation with our target variable. Maybe elevation is not a good indicator because elevation is only linked with only 2 variables out of the total. It is showing good correlation with only 2 variables. We will talk about it, which means most of the elevation is not needed in our data, or elevation is not a good kind of like feature for prediction of site EUI. So this is something I noticed when I was doing correlation analysis, which I will show you. So for temperature, the distributions were kind of like pretty much same. One thing which we need to keep in mind when we are doing feature engineering, that all 3 temperatures for January are telling you they are highly correlated with each other. The average temperature, the minimum temperature, the maximum, they are highly correlated. If they are highly correlated, which means it's no use that we use all 3 of them. Maybe we can just pick the average one and use that maybe. Or what we can do is we can pick the average one, and then we can find the range between max and min, subtract minimum from the maximum and create one new column and use that column and the average column, 2 of them instead of all 3. So we can engineer some of the features this way during the feature engineering phase. So this is what I did not do, but this is something I wrote down, and for the next step that we should be trying these particular strategies. So we can engineer some of the features by combining several different features in the data. So we can work towards that. So all the temperatures were similar. So that's why I'm not going to talk about all of them separately. Let's move on to the features which comes after the temperature, like precipitation. Yes, we saw that precipitation and wind. I saw that there is a very good correlation between precipitation and wind. So those wind features, they have very good, because we can understand, it's common sense that if wind is pretty high, precipitation would be affected by that. So there is a correlation in that particular manner. Similarly, heating days and cooling days, they were really good features because they are showing very good correlation when we look at the end. And you can see we have data for all of them. That means these are pretty good features that we should keep in our data. And you can see the distribution, the kurtosis is pretty good. So this one is very kind of like close to normal distribution. This one is also not as much like this, but pretty close. Then we need to kind of like work toward this average temperature. What this average temperature? So I think this average temperature is one of the features they created out of the average temperature from the rest of the year. So since we have average temperature for the whole year for that particular building, I think they created that in that particular manner. So we will, when we are doing feature engineering and feature selection, we will see whether they are correlated, or if they are, then maybe just use this or create another feature out of min and max for a specific month, and then drop the average one maybe. So because we don't want the information to be repeated multiple times. So we don't want kind of like repetition. So that way we can kind of like be very careful. Snowfall inches, snowfall depth, snow depth inches or something. This is yes, pretty good. We don't need to do a lot with the kurtosis and skewness and outliers, because yes, these outliers are acceptable, not that many. So let's keep them. Then I did is days below. Okay, so days below 300 F, what I saw is There is a column, this one, days above 110. We are dropping it from our data because it is just one single value. That means it is just empty values. That's it. And we will see that in the correlation matrix. It will show you that it has NaN values instead of zero correlation or something. NaN values, that means the values are not there. How would you find the correlation for that? So then these win columns, I figured out that there are a lot of values over here, and there are a lot of values here, nothing in between. So maybe we can kind of like assign them binary numbers. One when it is zero, maybe zero when it is zero, or maybe one when it is kind of like when it's kind of like above 300. So we can maybe create two categories instead of giving them numbers or something, because there are so many values which are just zero, and there are so many values which are kind of like just one, and there are very few values which are kind of like 300, 340, 360 or something. So there's one value, I think 280, then 300 and 310, 320, 1, 2, 3, 4, something like that, these values. So these are the things we will be working towards in feature engineering part, because remember I said the direction max win, these are telling you about one building for the rest of the year. That means if we have data for 7 years, that means if we know the value for that building one particular year, we can guess that, or we can copy and paste that value in the rest of the years as well. So this way we can kind of like fill up our data, and these columns would come in handy in that particular scenario. Then we would have to see, when we fill it up, then we would have to see what is the correlation and how they are kind of like related with other variables, and then we will decide whether to keep them or drop them or something. So I think this is something we need to work on during the feature engineering part. Then we will see whether to keep them or get rid of them. Then site UI, days with fog and age. This is the distribution. Site UI, yes, it has some outliers over here, but if you remember in our facility size or floor area thing, there were buildings which were pretty big, like universities and everything, which were pretty big, which means they would have a bigger SI site UI values. So they are not technically outliers, they are realistic values, but since they are not that many, so we will just leave them as it is. Or if we want, we will see at later. Over here, you can see kurtosis is 44.5. If we try to fix it, we can fix it by kind of like maybe going around 400 or maybe 600. We can try how many values are being dropped. And if the values are not dropped as many, we can just drop it, and we can, because we have a very big, large data set, that means that is the advantage of a big, large data set, that you have room to kind of like get rid of some of the missing values, and that would not affect the overall data. So because statistically normal distribution or things like that, if you have more than 30 values, a data point or something, now you can apply all the statistics of parametric test and everything. So that is kind of like 30 is a good number. If you have 30 data points or something, we have 75,000. So that means if we are losing 400, 500 or 1,000 or 2,000, that's acceptable. Now, bivariate analysis, we did the correlation. One important thing, correlation is one of the hypothesis testing strategy as well. We call it Pearson correlation number. So technically the number that we are getting, this is a Pearson correlation, and this strategy is also considered as a hypothesis testing, which kind of like tells you, gives you a number between -1 and +1. And based on that, it kind of like tells you kind of like how closely two things are related, whether they are related or not. All the hypothesis testing, that is what you are doing. You are comparing two variables, their mean or maybe their median values. So in parametric test, you are comparing their mean, whether the mean of both the distribution is closely related to each other or not. If it is not, you will accept or reject or the null hypothesis, depending on what hypothesis you are forming. So Pearson correlation is one of it. It is giving you that number, and based on that number, you can just see whether there's a correlation or not, whether it is strong or not, what you need to set as your threshold value. For example, you can see this is site UI. So this is the correlation value, 0.045. Since we have a lot of variables, yes, this is a pretty small correlation, but still, it is good correlation. Why? Because if you look, there are some values, the correlation is 0.01. It is below 0.01. It is 0.00 something. Those are the variables which are pretty obvious we can draw because they have no correlation whatsoever with site UI. For example, like this one. So 0.008. That means it is pretty small. All the others are around 0.01 and above, but this one is less than that, which means this variable is something we can geek out. What exactly is this variable? We can see at the top. This is October average temperature, which means October average temperature is not giving kind of like good correlation over here. Similarly, then we can also see some other variables. I think there is one on this side. You can see this is the NaN values, the temperature above 110 degrees. We can kind of like straight away drop it, and which we would be doing. Then you can see the correlation over here with the wind. When I plotted these particular things, what I did is I used drop the NA values, which means I don't want the NA values to affect the overall correlation. So what I did is basically while calculating the correlation, I dropped the NA values and then I kind of like looked at the correlation, which means only the values we have, let's find the correlation based on just that. So when we did that, you can see the correlation is pretty good with these columns for site UI. That means if we can work towards filling the missing values, these columns should be pretty handy, because these columns, you can see the correlation is higher than several other values. For example, this particular column, it has higher than that. Then if you look at the last column, for example, that we saw here, maybe this one is elevation, which means it is way better than elevation. That means we need to kind of like work towards which columns to keep and everything based on. So correlation is giving us a good indication. Now what I did is basically I made a correlation matrix over here. So you can see, so these are the correlations between temperatures, only and only temperature columns. I plotted it, and you can see that the temperature correlation between, for example, like January minimum temperature, January average temperature, and January maximum temperature, it's pretty red. That means it's pretty high, and which is obvious. So that's why it's not recommended to just keep all three columns. Just keep one of it, or maybe engineer one column by combining all of them up in somehow that we would be doing in feature engineering section.
Could I present now?
Later.
The time?
Yeah. So 11:10.
Okay, that's good.
Sounds good.
Yeah, thanks.
Okay. Sorry about it. So, and then over here, you can see that this is site EY. You can see this is pretty red. That means energy star rating. Yes, it has a very good, and you can see this fog one is also darker. So that means fog is a very good variable. So we need to come up with some strategy during feature engineering to fill up the missing values. There are 60% missing values. So we have to kind of like work towards it, because if I drop the values, then it is giving a very high correlation. So after energy star rating, this one has the highest one. So we need to kind of like work towards it. Then you can see over here, there are some brown ones as well, but they're not as dark. But this is the second darkest one. This is the first darkest one. That means these are pretty strong indicators. So then I plotted all of them up, scatter plots. So what I'm going to do is I will not use it. This is pretty big, but I will just quickly show you hypothesis testing. So so Z-test is one of the tests. So if you want to just look at the or test it for whether for certain hypothesis or something, you can just use a Z-test. What exactly Z-test does is it entails calculating the p-value. P-value is the significance value. It tells you the probability of happening something. The hypothesis that you set up, what is the probability of that hypothesis to be true? So if that probability is pretty low, that means you are rejecting the null hypothesis. If it is pretty high, you would say you would accept the null hypothesis. So we implemented over here this assumption. So my null hypothesis was, is floor area significantly different than site UI? I wanted to test that. So I put these variables in this particular formula. So this is something which I used from Rich. Rich uploaded a template, and I use that template to figure out this Z-test. So it is already on there. So you can, I just changed the variable names here, and I got the result. And this is telling me that acceptation. That means it is telling us that it is significantly different. But keep one thing in mind, floor area is not normally distributed. So Z-score is not a good, reliable hypothesis test in this particular scenario, but I did it just in case. But keep one thing in mind, in majority of the situations, you would see, read in different articles that Z-test cannot be used if data is not normally distributed. But if you have large enough data, you can use it. So which means in this scenario, we are using it. It is giving a good indication that yes, they are significantly different, which means we can use them together. So if they are different, that means that's what we want. If they are pretty similar. So t-test is another one, is an inferential statistic that is used to see if there is a significant difference between the means of the two groups. So which means it's kind of like the same thing. Here we were using the Z-score. Here we are using the T statistics. So Z-score is kind of like the standard number. When you convert your normal distribution into standard normal distribution, that Z number is basically used here. Here they are using just the mean values. So when you see the implementation, I'm just using the, so this is from the SciPy. It is kind of like calculating on its own. But I implemented one of the formula at the top over here, which is going in detail. It is using SciPy, but it is showing you what exactly we are calculating as well. So if you want to take a look at that as well, do take a look. So I added some links as well. Do explore these links for every single test. For example, this particular test, you can look at the documentation. This particular test, you can look at the documentation over here. And then comes in the chi-square test. Chi-square test is comparing the categorical variable. Since our target variable is not that one.
Yeah, meeting about to end, Salman. So we should start a new one.
Okay. Okay, let's restart again. I think I need just 5 more minutes and I would be done. Yeah.
Oh, good.
And then can you let me share my screen, please?
I gave you access.
Yeah, I have. Okay, so chi-square test is for categorical. That's why I did not run it over here, because we are not comparing, means our categorical variables. We will encode them and everything, but if we wanted to compare here, this is the kind of like complete code for it. You can just put in and play with it. But I just wanted to show you that correlation that we used is a very reliable indicator. And since we are getting all the information from it, just for the sake of understanding and knowledge purposes, I'm sharing all the codes and all the steps that you need to do for Z-test, T-test, chi-square test. Now, these all 3 are parametric tests. Parametric means they are dependent on the mean value. Whenever the mean is a good central value or shows you a good information about the distribution of the data, you go with the parametric test. But in our case, majority of the data is not normally distributed, which means median would be a good number. There are a lot of outliers. When there are a lot of outliers, non-parametric test is not affected by it because they use median value. So Kruskal-Wallis is one of the tests I implemented, but these tests are pretty straightforward. Here I'm doing stats.kruskal, but if you change the number to Friedman, this name to Friedman, it would give you the Friedman non-parametric test. If you change the number to Wilcoxon, it will change the Wilcoxon one. So there are so many non-parametric tests, a bunch of them. And Kruskal-Wallis is something industry standard. I have seen a lot of people using it. When I was taking courses in my university, professors talking about it and using it more often than the other ones. Yes, they did talk about it, but Kruskal-Wallis is kind of like an industry standard. Majority of the people use it as a non-parametric test, as I have seen based on my experience. So these are a few tests. Just wanted to share that. Then scatter plots, I did scatter plot. Remember last time I was saying that instead of using pair plot, because pair plot takes a lot of power, you can just break it down. I can use pair grid, and pair grid is I can fix my X value, which is site UI, and I can put all the column names. For this particular purpose, I just plotted a few of the variables, but I can plot all of them. So I can repeat this particular code again and again for the remaining columns, and I can see the distribution, how the distribution is affected. And I can put a reg line because I can change some parameters here, and I can include. So right now on default, by default, the regression line is kind of like set as none, but I can turn it to be true, and it would show me the regression line over here that can show you whether the correlation means relationship as linear or what kind of a relationship. It can only tell you linear, but whether it is positively related or negatively related or something. So I think that's it. So we gather a lot of good information from this EDA, and now we know a lot of variables that we need to work on during the feature engineering part. So I think that is it for this particular EDA section. If anybody has any questions or anything to add or something, I'm open for questions. You can ask me. Imran, you were saying something?
I just wonder, on a few places there was some big chunk of codes which you commented out. I don't know if you covered already. Why did you comment it out, or do we have to ignore it?
That's what I was saying. For example, like this chi-square, I did not implement it. This is a complete way. So this is I copied from Rich template, but for some reason I did not understand what is happening here. I just commented it out, and I just searched for another one, and I tried to implement it from the other strategy. So this one is something I was not able to interpret what exactly is happening.
Explain us this, right? If you want to
means so this is a copy paste from his template, so I think he should be able to, but I did add the where did I do it? So Kruskal-Wallis is here. Chi-square. No, I did not do it because it was giving me error somehow. So fine. I need to work on it. Yeah. But other than that, over here, I commented it out. For example, these hypothesis testing, these are the ones which are kind of like showing you breakdown of everything, what exactly is happening under the hood of those SciPy commands. So these SciPy functions, they can give you answer right away, but you don't know what exactly is happening. But this way, you know what exactly you are calculating. So you can see that this sigma 1 is technically the standard deviation we are talking about. You are squaring it, which means you are taking the variance and dividing it by the total number of possible sample size. That means and plus the standard variance of the other one, and then taking square root. That means overall calculating the standard deviation. And then finally, you are subtracting x1 and x2, which are the mean of the one column and the other column. You find the difference between them and dividing by the overall standard deviation. So this gives you the z-score. So it is telling you how we can calculate z-score and use that z-score in our calculation without using SciPy function. So here we did not use this SciPy function, but after that I showed the SciPy function as well. So which means anybody wants to implement directly from SciPy, they can do it. If they want to understand the mechanics behind it, they can send it this way and they can implement it this way as well.
Thank you. Any questions, anyone?
Yeah. Anybody, any question? I know that parametric, non-parametric is something which is confusing. If you have question, ask me. Yeah.
I had a question about EDA. Most of the EDA that we've looked at doing so far has been what I would call like data agnostic. This is all just like running the mean, the mode, the median, doing paraplots and correlations, but we didn't. So one thing that like we looked at the like distributions of the data, but we didn't look at the distributions of any of the data based on like any knowledge of the data. So like we know that there's 7 different states that are represented in this data. I went through and ran did several of the distribution plots based on, instead of just plotting everything on the same distribution, plotting them state by state, because your averages for temperatures would make more sense, would be based more on your physical location than your building. So like anything that you're going to have like variance on that. And like similarly, like one of the questions I have essentially is that like our data covers a very wide range of things, several different states, a whole bunch of different like things. And when we're looking at the data, like when we're doing EDA, are we taking any of that into account, or are we just like, this seems very, I don't know, dispassionate, like we don't care what the data itself is. It seems much more like we only care about the numerical, like qualitative aspects of the data. Is there a portion of EDA that should include a more like?
Yes, means so that's a good question. You can just add, so I just added over here, you can just add a hue factor, and now it's going to give you the scatter plot based on the facility type. So it's going to give you scatter plot. It would divide all the facility type with different colors, and it will show you the distribution. Yes, we can play with that. But since we had 1 week and we covered a lot of stuff, yes, there are a lot of things we can do, a lot of things. Yes, you're right. We can do these hue plots and everything. I did not get the chance, but I'm telling you, if you just put the hue column here and you run it, it's gonna change it. But right now I'm using train only numerical variables. But if I use the train number, let's say train, and let's plot it. Let's see what we get.
Hey Salman, I have done something what you are saying right now. So if you can open whatever I shared on Slack, probably like you can see those plots.
So I don't have Slack on my computer right now.
It's okay. I'll share the screen.
Yeah.
Once it's done. Thanks, Melissa.
Okay, so Imran, can I share mine?
Yes.
I just got the plot. So yes, this is what you were talking about. So now you can see the data is kind of like distributed based on the facility type. You can change it, maybe year factor over here. Then it would change it based on year factor and so on. So we can kind of like play with that. And yes, it would show you a lot of things. But since we have 60 variables, it is taking, so just this particular plot, it took I think 41 seconds, because I'm just plotting 4 of the variables. If I do it with 60, it is taking a lot of time. And yes, on my end, I tried it, means I just showed it because this is what we can do. But in the available time, we covered a lot of stuff. Yes, this is something I would recommend anybody, please try to do it. And if you can get some insight, that would be amazing. But based on the time limitations, this is what I was able to do in the time that I had. Yes, you're right. This is something we can do. Yes, that's now, since we have 3, in fact, 4 categorical variables, we made one of it our own, the year factor. So we can try it, we can figure it out. So these are just 4 plots. That means for one single column or one single site EY, I need around more than 12 rows of these columns that would just describe one particular means in fact not one particular site EY. and then I would have to do it based on year type. Then I have to use based on the other categorical variable and the fourth variable, which means we would have kind of like more than I would say this is 10 times 4, around 40 or 50 rows of just graphs, and then we would have to gather a lot of information from it. Yes, it would be a lot, but we can get it. So yes, that's a good question, and that's a valid question. And based on the time limits, since this is means some of you did share something, means I think Manasa uploaded something on GitHub. I checked it out, but I think it was based on test. I was not able to interpret it. Means how I can use it in this particular EDA part. But if you can explain it, what exactly it was covering, that would be amazing, because this is what I was able to do. Yeah.
3950. Manasa, do you have to show something?
The problem is I'm not able to like connect Zoom on my laptop, Imran. I have issues. That's the reason I shared the file on Slack.
Okay. Let me see.
Probably like you should open it on Jupyter Notebook directly, or you'll have to open it on Google Colab.
I never tried Google Colab to open this file, so I'm just not too sure. Let me try very quick.
Yeah. I'm trying to log into Zoom on my laptop, but it's not connecting. I don't know what's the reason.
Sorry, guys.
It just has the visualization what someone else was asking right now. So it's like more of like 2 to 3 variables included against the target variable. So that's the visualization.
Let me share my screen. I've downloaded the file. How?
Means if you have it, then yes.
I guess that's the one, right?
That's the one, right?
I have it up on my computer. I was able to
Guys,
download it.
anybody can share. I think it's slow on my end. Do you want to share Michael?
Sure. Yeah. Hold on one second. There you go. So this is the
Yes.
That's better.
file
Thank you.
that she was
Yeah, that was
discussing.
Right.
And so what she did one, she was able to plot the various, some of the data again, including the labels, the different factors against one another, which I think does kind of show some of the information that I think I think that my question was just kind of like this data covers such a wide variety of things, and I think what I'm trying to understand is that, like, we can, like, when we start to talk about like pruning data and feature engineering, which is what we're about to get into, my thought is that, like, we can make a very precise model for certain things by just simply eliminating like most of our data. Like when we start talking about like getting rid of like, larger buildings, like those, like we're talking about outliers. And I think the thing that in my brain that I'm having like a problem, I guess, getting around is that, like, the problem is that we don't actually have a lot of outliers. We just have data that covers a whole bunch of different categories. So, like, in my mind, an outlier is like a value that doesn't make that doesn't line up with reality. It's something that is like, it's like Bill Gates, salary or whatever, where he makes like, millions of dollars, but the average person makes, a reasonable amount of money. That is an outlier. But like when we're talking about buildings, when you have a warehouse, if you have a whole bunch of warehouses, they all have huge square footage and huge energy usage. And so like, that's not like, those aren't outliers, but when you have them grouped with houses, like single and multifamily homes, like this data does, they appear to be outliers simply because they're not being grouped. Like, if we grouped Elon Musk and Bill Gates together, those numbers make more sense together. I think I've been looking at the data a lot and trying to understand like how, like what this data is trying to tell us. And it feels the data itself just feels very disconnected, at least for me. But this is a great file. The correlation matrix, like the information here is excellent. And there's also like breaking down where the different things are coming from is super, super helpful. So
Thanks, Mike, and thanks, Vanessa. Thanks for sharing
I
that.
have a question.
Thanks, Mike, for sharing.
Yes.
Yeah, hi. I have a question regarding like bringing the hue aspect in scatter plots. Like Michael said, it's a lot of variety of any variables that we are talking about. But does scatter plot give you the right picture, or even the picture of what it's telling you? Like, I cannot figure out in any of these scatter plots which area has more observations or whatever. What am I getting out of the scatter plots? Even if I bring in those, like grouping them together, am I getting anything out of it?
So I think so because it is telling you one important thing, that the data is kind of like all the data that we've collected. For example, all the facility type, the data is distributed all over the place, which means it is not clustered somewhere, or it is showing you a relationship that this particular facility type is kind of like at the higher end, at the lower end, or something. So which is kind of like an insight that we are getting, that we don't have kind of like this facility type always have data in this particular at the top of the graph, and this particular facility type at it is kind of like pretty low or something. So that's what it is showing you. And I think Michael made a really good point. That these things and everything. So outlier thing, I want to kind of like share what I think about it. So yes, you are right. There are some values which are kind of like realistic, but in terms of data, for example, we need every single value. For example, like we do sampling when we collect data, because we cannot go and ask, for example, if I want to do a particular questionnaire, I cannot ask every single person in the world. I can take a sample of people and I would just ask them to take the questionnaire. And based on that, so that sample, how exactly I'm randomizing the sample, that determines how good that data that I would collect would be representing the whole population. So if this particular data has a lot of information for majority of the buildings, which are pretty small, but there are few buildings which are giving you the realistic answer, but they are not telling you, or they are not representative of all the building. Means they are kind of like not what I'm trying to say is, yes, technically they are telling you the right thing. They are correct values. They're not outliers, but based on our data, they're not good representative of that data. And they are skewing the data. And since there are very few values, very few buildings, let's say out of 75,000, there are just 500. 500 is a big number, but if there are just 100 of them, then those 100 are not good representative of all the buildings in the data that we have. So I think that's what my take on it is.
Just one quick thing. I'm gonna share my screen again, just real fast. So there was asking about what this data shows on this site EUI versus Energy Star rating. One thing that you can see from this is that you can see that there's a slight stratification based on type. And so like the Energy Star ratings, like all the buildings seem to have an equal spread across the across the range from 0 to 100 on Energy Star rating, but there are layers of stratification. So like it appears that warehouses or warehouses down here at the bottom are our green areas. Those seem to have the least site intensity. And then above them, you have, you have commercial, industrial, and then you have office buildings like in the middle, along with several other things. And so you can kind of see that like service facilities seem to have more energy usage at the same Energy Star rating. And so like, does that provide us with something, that's necessarily useful at this time? Maybe not, but it is a that's one way that you can kind of read these graphs when you have multiple different labels all just kind of layered on top of one another, if that makes sense.
Yeah, thanks, Michael.
Thanks, Mike. I think Salman and some other people have some work commitment. That's why we, thanks to our past leads, we are arranging an extra class on Friday, same time, 9 to 10. I guess we had a lot of material today to cover, so I think it might be helpful if we can bring some of our query that time and hopefully absorb. And yes, and I think, yes, we can cover that. If somebody has any concerns, feel free to post on the respective channels as well. And well, will it this time be fine? 9, because based on the poll results from last time, it was 9 to 10 a.m. was fine for the majority. This is why we are thinking to organize extra class in which we can break down the feature engineering task as well as this particular task. Looks like people have a lot of queries and some of you have great suggestions. We really wanted help, like if you guys can suggest what can we do in terms of promote effective collaboration. Like we tried GitHub and now I tried Excel. What if you guys can, any of you can appreciate any idea or anything in terms of any software which we can use in which people are more comfortable to share their ideas, please help us out. So at least it will, in the end, it's only going to help all of us in terms of our overall experience in terms of learning wise. But we really appreciate in terms of Minissa and Mike and all of you whoever bring the very deep insight questions. And I think let's just continue on Friday. And same time, 9 till 10 a.m. Eastern time, right? And if anybody have any questions, please feel free to post on the chat on the group. Okay. Thanks, everyone. Let's continue on Friday. Thank you.
Thank you.
Bye-bye. Take care.